Okay, from yesterday, is it worth our time going through another example of a two-step problem? Yes, no, you tell me. No, those are three-step problems. Okay? How many of you felt comfortable yesterday? That I would venture to think it must be all of you. All right? So write these down. I would suggest that you do, but that is your personal choice to write them down or not write them down. Of course, you can always take initiative, come back to the Science Channel, or seniors can probably help you out with this, just like maybe you could help the freshmen out if they asked you questions about the slide rule or Bohr models or configurations. Of course, for you individuals, that's old news, right? Okay. Fair enough. But keep in mind when you're approaching these problems, you always have to have what before you can proceed any further with your 3.5 moles or your 350 grams of tin for hydroxide. You have to have a balanced chemical reaction, yes. And also before we proceed much further, due to human nature as it is, it's quite possible what mistake may, I'm not saying you will, but what mistake may people make? The most common mistake. Yeah, not placing twos behind elements that are diatomic. Would anyone like to volunteer to come up here and make an attempt on these? Yes? No? Okay, fair enough. We ready to go with that top one? Okay, so how many grams of hydrogen are given off when hydrogen chloride decomposes from or with 3.5 moles of hydrochloric acid or hydrogen chloride, whichever way you want to refer to that. So, what happens when something decomposes? Okay, so what is it that is decomposing? Okay, so here we have our HCl. Okay, so we're giving you that compound here. All right, so you correctly said something breaks apart. So here's our reactant side. What do we have for products on the right side? Okay, hydrogen and chlorine, because that's what the two elements that we have. Okay. What about it? Which one? Okay. Is it just hydrogen? we got that done. Next thing we do is what? Okay. Is that right? Okay. So, now we've got a reaction. It's balanced. So, decomposes from 3.5 moles of HCl. So, we're starting with 3.50 moles. So, what is the question asking? How many grams of what? Okay. Sometimes we say how much or how many grams. We're talking about a mass. So it's X amount of grams here. So we don't know. Now, you don't have to put this up here, but there again, when you do approach these problems in that fashion, it then allows you to remember what it is you're essentially looking for. Okay. So what's our next step? Taking 3.5 moles of HCl and doing what? Remember, what is significant about a mole ratio? So if we have 3.50 moles of HCl from last semester, we said a mole ratio allows you to change what you have into what it is you're looking for. 3.50 mole of HCl. Didn't do much better. Okay. So how do we get that mole to cancel in our next step? Okay, so we want to put moles of HCl on the bottom. Remember, this mole ratio allows you to change what we have, which is this substance, into what it is that we're looking for. Okay, so with that, you correctly said moles of HCl goes down here, 2 moles of what goes up on top there. Now, you can write it like that, but this is one of them examples that we say if you're off by a factor of 2, it's probably because what? Because if you, and everything's written correctly up to this point. Yes, that is moles of hydrogen, but yesterday, what did we say? What's always good as, it's always going to be beneficial to have what habit when you're dealing with these gases. Yeah. So when you always do that, okay, so even if this question was asking how many moles of hydrogen are needed, do you need that little 2 there? No. No, you don't. That won't have any outcome on the problem. But now when you're looking for a mass, yes, that would have an outcome on the problem. So every time that we see a mole over a mole, that's our mole ratio, and then we have to go back to our reaction. Do we need any coefficients in that problem? Answer is yes. Okay, so we go back to our equation. How many moles of HCl are there? And that 2 comes from here. Okay, so we put our 2 there. These have canceled. We're done. We just have that last step. So, how do we cancel out moles of hydrogen? Put it on the top or the bottom? For every mole of H2, we get how many grams of it? Okay. so where are we talking at? Okay. Up here? No. No. You are referring to that's how we solved them last semester, right? Yes, that's correct. Is this what we got? Yes? No? Yes, because that 2's on the bottom. Is it really going that smooth, or are we just lost? Right. How many of you think that's right? Correct. That's what I said. That's what we did last semester. All right. Yes. Now, the reason for that, this is what's throwing you off. Okay? With last semester, we're dealing with only one compound. That's compositional stoichiometry. That's what we read yesterday. We're no longer doing compositional stoichiometry. We're doing what instead? Reaction stoichiometry. Those are two totally different concepts. That's correct. Okay? Remember the example we gave when the official says this? It's always good practice to carry them twos, correct? So when something like that happens, you don't forget to double that. Okay? So yes, 3.53 is your answer. Yes. Okay, can we proceed? So middle, are we good? Okay, left middle, right outside. Okay, left outside, right middle. Okay, very good. So, how about this next one? Just as a slight review from last semester, what type of reaction do you think this is? We see tin 4 hydroxide. Is that an element, molecule, or compound, do you think? It's a compound. What are we reacting that with? Is that an element, molecule, or compound? It's only an element, so we have a metal that's all what? All by itself. That's a very clear indication of what type of reaction. Single replacement. All right. So we've got tin 4 hydroxide. Symbol for tin is what? Okay. The hydroxide ion. Okay. Said go by your negative ions. Hydroxide has a charge of negative what? Okay. So what's the charge of tin? Okay. Those don't add up to 0, so what would we need to do? Okay? Okay, so we're reacting that with aluminum. Okay? Even though it's not bonded with anything, what type of ion will aluminum form? What would it tell you either on that table or yours? Well, we're doing this single replacement. Okay? So what gets replaced in this compound? Okay? Is that right? Okay? What's the next thing we need to do? Okay? So, do you want the elements and molecules written out, or can you visualize that in your head? Okay. Asking for input. Input said visualize it. Is that right? Okay. Where should we start? There's only one place you can. The only ones that are out of balance are, what is it, the tin, the hydroxide, or the aluminum? Hydroxide, because that number is 3, that's odd, these are even. So, to get that up to an even number, how would you get 3 to an even number? We could try a 2 here. Okay? But will that do anything for you? No. Or you can look at the 3 and 4 like you already did and say what's the least common multiple, which is what? 12. Okay? So putting a 4 there. 4 times 3 gives you 12. So 12 divided by 4 gives you what? We've got 4 aluminums over there, and how many over here? So you have to put a 4 there. Do we have to do anything to this tin? Now, is that going to have any bearing on the reaction? And yes, it will. Okay. Okay. So, oh, what did I do that for? Maybe see if anyone's paying attention. This is good. We got such a good sense of humor in here that everyone's laughing that they're not going to fall asleep. All I see is a bunch of scowls. Is this material really that bad? It's definitely. Okay. The sun's not out. That's what it is. This was what, 4 aluminum. We had what, 3. Yeah, there we go. Okay. So, to finish this, we have 353 grams of this. Okay? And it's asking how many moles of tin. Okay? How many moles? Well, we don't know. That's what we're going to solve for. Okay? So, 353 grams of, and we can abbreviate this and just say tin hydroxide. Okay? Because you can always refer back to your compound here, tin hydroxide. All right? So, we see this number in grams. We're going to change it to what? We're going to change it to moles. Okay? So, for every grams of tin hydroxide, we would get a mole of tin hydroxide. So, let's see here. 118.71 times, oops, not times, plus. Sixteen times 4 is 64 plus 4.04 for your hydrogens. We get 186. Is that right? Okay. Now, we've got moles of tin hydroxide. Do you think we need to put a 3 here? You are correct when you say no. Why are you right? It says 3 there. We said the only time you refer back to this equation is when you have what over what? Moles over moles. We don't have that. We have a molar mass, moles per gram. Okay? So these have canceled. We're in moles of tin hydroxide. So we want that mole of tin hydroxide to cancel here. And then what would go on top? What we're actually what? Moles of tin, because that's what we're looking for. So there again, we've got a mole ratio, which means you have to go back to your balanced chemical reaction. And should you have forgotten this step, would you still get the problem right? The answer is yes, because we're putting what over what? How many moles of tin hydroxide do we have? Okay. How many moles of tin do we have? So those would have canceled each other out anyway. So sometimes it does work out. Okay. So 353 times, or we don't even have to do that. We can divide. Divide by 186. 1.89. Is that what we get? 1.89. Okay. Are we good? So left outside, you good? Left middle, middle, right middle, right outside. All right. So next week we'll probably have a worksheet for you to work on. Because our first activity, we combine the two when it comes to changing a mass to a mass, along with limiting reactants and percent yield. We combine them all together in an activity, but that won't be until a week from last Wednesday. Would be the 15th. So maybe somewhere around the 20th or so. It takes quite a while to get through this chapter, just because it is so large, because we have these types of problems, limiting reactants, and then also percent yield. All right. So one of the things I tell the classes, when it comes to this, if we're struggling, please take the initiative to either come back to this channel, talk to someone who knows how to do these, which would be the seniors, if they would remember, or come in and talk to myself. It's your responsibility to take that initiative, okay? So unless you're sitting on the very outsides, then I say look left and look right, okay? And if you get knocked down, ideally there's someone there to help pick you up. But again, that is your choice. All right, we'll catch up to you next time.